Bonjour à tous, nous vous souhaitons la bienvenue dans cette conférence sur les smart grids dans la prolongation de notre série sur la troisième révolution industrielle. Donc c'est Henrique LIAN qui aujourd'hui animera cette session. Donc Henrique LIAN de l'Institut Ethos. Et donc je vais inviter à rejoindre sur scène à mes côtés, ainsi que les intervenants de la conférence, à qui je vais laisser le soin d'Henrique LIAN de les présenter. Henrique LIAN can join the stage.
Merci beaucoup. Je vais remercier le réseau Alliance pour l'aimable invitation de modérer ce panel. J'aime la langue française, mais je voudrais parler anglais, si vous me le permettez. Mais à la fin des premières considérations de nos conférenciers, il y aura une session de questions et réponses, dont les questions peuvent être adressées à la fois en anglais et en français aussi. So I would like to call our speakers, our very special speakers, to the stage. Mr. Emmanuel de CORTE, Service Line Leader Markets and Regulation from DNV Kema in the Netherlands. Thank you so much for being here. And Mr. Roch DROZDOWSKI, from GrDF Strategy Division. Please, sir. Thank you so much. Yesterday, we had a very interesting section on third industrial revolutions, growing in renewable energy. So we talked about the need for as fast as possible transition from fossil fuels to renewable energies, towards more energy efficiency, and so on. And now today, we go deeper in the fourth pillar of the third industrial revolution theory and talk about the intelligence needed for making this transition happen. As we talked yesterday, to talk about energy is to talk about complexity, to talk about a very intensive, capital-intensive sector. And when we talk about intelligence for energy, we're talking about a world of possibilities. I would call it a what-if world. So what if energy companies knew exactly how much energy each of its consumers needed at any time of the day and could send that exact amount, avoiding losses and overpower? Or what if we could generate our own energy at home through solar equipment, for instance, and knew how much and at what time we could sell our surplus to the local energy company? And what if part of our surplus could be charged in the batteries of our own electric cars? What if energy companies could detect a problem in the grid in advance and repair it remotely from long distance, and so on? The list is so huge, is so large. So we'll have the chance to listen to two experts who have worked with this and try to understand how much we have advanced, what are the gaps we needed to cover, and to address questions to them. So I will ask our first speaker, Mr. Emmanuel de CORTE, for his presentation, please.
Dear Mr. Chairman, dear ladies and gentlemen, mesdames, messieurs, bonjour, good afternoon. First of all, I would like to thank you for your introduction, and I would like to thank the organizers for having us here today. We feel really honored and privileged to be here, and as an energy consultancy company, to share our views with you on smart grids, smart metering, and the future. My presentation this afternoon, and I will try to stick to the given time, has actually a twofold approach, and I would like to give you two messages. First of all, I would like to show you the massive impact of smart grids and smart metering on the structure and the functioning of the energy market. And secondly, I would like to show you that having smart grids and smart meters is no science fiction. It's reality, and it's going to happen soon near you. So these are the two main issues in the presentation. Before we have smart meters, we should try to find out how this works. No.
Oui, il marche pas. Ah oui, il est pourtant sur on. Il est sur on. Un petit bouton blanc. Ah oui. Ok, c'est bon? Ok.
Merci. Okay. So first of all, who are we? DNV Kema, Energy and Sustainability is actually the name of the company. We are actually an energy consultancy company. We have approximately 2,300 experts all over the world. We recently merged our power, and together we combine and we offer almost 150 years of experience. We have, as Kema, our headquarters in the Netherlands. We are based over there. But as said, we have offices all over the world in several countries, spreading over 30 countries worldwide. We are part of a much larger group called the DNV Group, actually combining three specific departments. We have what we call DNV Kema Energy and Sustainability, working in the field of energy consultancy and smart meters. We have DNV Business Insurance, and then we have DNV Maritime Oil and Gas. So together we have approximately 300 offices, a team of 10,400 people, and we have in our portfolio more than 100 countries. Let me talk to you about what we do, our activities. We actually span the whole value chain of energy. We try really to serve the needs of the energy marketplace. We not only work in the field of energy policy and strategy, and this is really the field where smart meters play, but we also offer consultancy services in the fields of production, trading, transport, distribution, and the use of energy. And that is also one of the areas where you have the smart meters. Let's now look at the changing world of energy. What we see as a global service provider is that there are actually 6 major trends to be identified in the energy world. First of all, we see that in regions such as Africa, Asia, South America, the Middle East, there is a dramatic increase in demand for energy and electricity. More and more electrification, more and more appliances, more and more people getting connected to grids, so more and more energy demand. But at the same time, we see that there is an increased attention for environmental responsibility, or so-called stewardship. When people talk about energy, more and more they talk about environment, sustainability. Thirdly, we see a major decline in the fossil fuel supplies. So fossil fuel is definitely on a decline and is being constantly replaced by renewable energy. When we look at the energy production assets, we see that most of these assets in specific areas are aging, and so is the workforce, which is good news, for some at least. We also see a tendency in the advancing technology. More and more there's some kind of an integration between traditional energy production and transmission distribution approaches and ICT. And finally, we more and more see a tendency, especially in specific areas and specific countries, towards maintaining a certain reliability. When we focus actually on the energy transition playing field, we can actually identify three major trends on the political, technological, and economic field. First of all, what we see at the political side is that in some regions in the world, there is a tendency towards liberalizing the market. And this is happening in Europe, whereby countries and the European Union are setting up a legal framework to really unify the market and create one single, well-functioning electricity and gas market. Besides that unification and harmonization, we also see a tendency towards a regional integration. More and more countries decide to join forces and to create a regional energy platform. As said before, we also see a tendency towards the integration of a climate policy, which is being reflected by the support for renewable energy, aiming at reducing the CO2 emissions and trying to benefit from energy efficiency. Nuclear debate is high on the political agenda, as is the security of supply. At the technological front, we see that more and more there is an enhancement of renewable technologies. Also there, initiatives are being taken to increase the efficiency, including the efficiency of what we call the more conventional, traditional power generation. We see a tendency towards efficiency on end-use energy. And we see electric vehicles appearing. We see new network technologies. We see initiatives being taken in the field of energy storage, dispersed or distributed generation, and we'll come back to that. And of course, the scope of this presentation, smart grids and smart metering. Finally, when we talk about economic aspects, we see that we have aging assets. We really, in some cases, have the urgent need to replace those assets. We see an increase in regional energy trade, but also very fragmented markets in some ways, a growth in demand, regional harmonization, and consolidation at corporate level. But what about the energy mix? What about the current and the future energy mix? And what is the role of smart meters in all of this? When we compare, and sorry for that, but these numbers are based on the not the latest report of the International Energy Agency, but the one before. When we compare the situation in 2008 and the presumed situation in 2035, we see that in some cases there is a dramatic decline in what we call traditional fuel sources, such as oil and coal, and that position is being taken over by renewable energy sources, hydro, wind, biomass. I invite you to have a look at the world map. You can see that in the United States, as well as in China, as in India, as in Africa, that increase is massive, and so it is in the European Union. This is just one scenario, and to show you the very large divergence between this approach, I'll show you another scenario, an ECOFIS scenario, whereby it is being put forward that by 2050, almost all energy will be produced based on renewables. So you see the spectrum is huge, from just a percentage to, by 2050, 100% energy production based on renewables. As I just told you, what we also see is that the scale and the priority of the energy business is shifting. Let me give you an example based on the European grid. resulting from a project we were involved with. If we consider that we want to integrate much more renewable energy in Europe, and that can be photovoltaics or wind, we need to rethink the whole transmission and distribution grid. And in the event of Europe, that means that we have to create highways. Because let's face it, the European grid has never been designed really to export and import energy over long distances. The original European energy market has been designed whereby you have the production very close, very near to the so-called load centers where the demand is. If you now are creating one single European market and you want to transport the energy over longer distances, you need a whole new energy grid. And this is actually what you can see. That means a new grid is more interconnection capacity between member states and more cross-border trading of energy between those member states. So this calls for some cooperation and coordination at European level. And this is actually what you see on this map, is how the European energy transport grid should look like in 2050 if you want to integrate more photovoltaic power and more wind power, coming both from Europe and from regions outside Europe. This is the first observation. The second observation is the so-called decentralization. It's local energy production, so distributed generation, which means that we see power generation now coming from very small companies, but even from citizens with PV solar panels on their roof. We very often in some countries also see power generation being done by municipalities. And all of this is really generating very innovative business models. I'll come back to that in a second. As I just explained before, the integration of renewable energy is completely changing the way we think, the classical way we think about market structure. In a very classical approach, we had power generation. We then have the transport over the transmission network. We have the distribution towards the end consumers. And then finally, we have services being offered to the consumers. So the main point here is that we have a one-way power flow from generation to end consumers with a very centralized generation, only passive networks. There is no linkage, there is no automation, and there is no communication whatsoever within that grid. And finally, the demand is very unresponsive. That is about to change, and we're moving to the next generation. And this is where smart grids and smart meters come into play. In the new market structure, we have some kind of central generation. We have a transmission network that is still being used to transport the energy. But here already you see that the transmission network is interacting with electricity storage. We more and more have the integration of wind energy with an intermittent character. But the transmission network starts communicating with the distribution network. And so instead of having a one-way flow, you now become a bidirectional flow between the transmission grid and the distribution grid. And as the consumers now become producers, you also have that communication between the former end consumers and the distribution grid. Besides that, it even gets more complicated, or more exciting, or more sexy, because we have the distributed generation and also electric vehicles appearing. Just to show you how dynamic it is, what you see on the upper right side of the slide is a very tiny picture of a study we conducted for a European country of the so-called energy island. And an energy island actually covers everything. It's a place where you can put up wind turbines, but the water surface you see in the middle is actually a massive pumped storage. So you can call it a massive battery where the energy is stored and you can use it exactly at the right moment where you need it. We've been talking about the new market structure, but actually the pivotal element within that is smart meters. So let's define a smart meter. What is it actually? Well, you could say it's a very intelligent metering system. And as just explains, it allows you to go bidirectional, to communicate actually between, on the one side, the consumer, and on the other hand, the supplier or operator. And so its aim, according to the European directive, is to promote services that could actually facilitate energy efficiency from your home. So on the one hand, they allow to monitor your energy consumption. And more important, with a smart meter, you're no longer passive, because actually you can change your consumption pattern and you can communicate with the grid. As said before, this is completely changing the old paradigm, because now demand can actually follow generation. It allows you really, as is shown on the slide, to interact. And it's a very intelligent way of integrating all the actions of all the users that are connected. So using that network, you can actually exchange not only energy, but also information. And so we see a smart grid and a smart meter as really a key enabler on the way towards the new sustainable and secure energy future with a very dynamic network. Let me show you, and then I come to the second element of the presentation, how it works. Because it's, as said, it's not rocket science, it's reality, and it's coming to you, it's coming to you rather soon. There are international developments in the field of smart meters and smart grids. I just wanted to give you here an overview of the real drivers why countries and regions opt for smart meters and smart grids. That can be peak load reduction, a shortage in energy supply, trying to reduce losses also in the grid, and trying to integrate as much as possible renewable energy. When we look at the abilities of smart grids and smart meters, well, we can summarize that. First of all, smart grids should be very flexible. As I highlighted before, it's interchangeable, it's exchanging information and energy. They should be accessible. In many cases where we conduct studies on smart meters and the rollout of smart meters, we see that governments really pay attention to the fact that it's sustainable in a way that all users can get access to the network, and so that smart meters and smart grids are available to all end consumers. And of course, it goes without saying, we live in a real world, it should be economic, and foremost, it should be reliable. In Europe, there is a tendency to integrate smart grids and smart meters, really fostered by the third energy package, because there, the European Commission said that every European electricity meter should be really smart by 2022. And that means that you have several initiatives being developed in Italy, Sweden, Spain, and other countries, aiming really at having those smart meters everywhere in Europe by 2022. For the time being, it is reflected by several demonstration projects on a purely component level, so not the general rollout. However, there are some projects in the Netherlands and also in Belgium whereby they try to really combine smart meters into smart grids in real-life situations. The same actually is happening in the US, where you have several initiatives. I think we should not go into the detail here. Several projects, including in Boulder, Colorado, and initiatives that have been taken at a more overall North American level. We see the similar evolution in South America. whereby Brazil is really taking the lead, and you have several pilot projects popping up, and also projects being started by private companies. Also in Asia and Pacific region, we see similar projects. There's a very large first real-life project in Jeju in South Korea, whereby they each time try to combine broadband, smart meters, and intelligent grid technology. I was a bit surprised, ladies and gentlemen, to see that we call it the third industrial revolution. Honestly speaking, I slightly disagree. Because if you look at the meaning of the word revolution, it means a swift and dramatic change. But smart grids and smart meters are not that revolutionary. It's a history, and it already started in 1989, where for the first time the word smart grid and smart meter started appearing everywhere in publications. In 2001, Italy and Europe started installing smart meters, and then, well, things developed rather quickly. In 2003, we had an initiative in the US. European technology platform was set up in 2005, and now, in 2010, we see larger projects appearing, like the one in Jeju, e-Energie project in Germany, and the Smart Energy Collective in the Netherlands. Please allow me, ladies and gentlemen, just to focus on the smart grid developments in the Netherlands. Smart grids and smart meters in the Netherlands is really one of the most important elements in the Dutch energy policy. The Dutch government has set up a task force, so-called smart grids or intelligente netten, and they started field trials. They put up an investment scheme, a subsidy scheme, so that those 12 field trials could be funded. And smart grids is only 1 out of 7 top priorities for the Dutch government. The Dutch energy policy concerning the smart grids and smart meters is actually built around 3 main pillars. Transportation, whereby the Dutch government thinks that the rollout of electric vehicles will become the mainstream. Local energy production using micro CHPs for local heating and electricity production, and then finally housing using smart home appliances and very innovative services. As said, several initiatives have been taken in the Netherlands at different levels. Some initiatives have been initiated by municipalities and regions, like Amsterdam, City of Amsterdam, the island of Texel, the city of Utrecht, even entire regions such as Energy Valley, which is actually covering the whole northern part of the Netherlands. But we also have initiatives taken within sectors, coming from the industry or even from grid operators. Smart meters and smart grids, ladies and gentlemen, is just a start, because we are actually moving to a new dimension. Smart energy cities. Smart energy cities is the next step. It is the integration of a market structure, smart meters, smart grids, into one single entity, whereby you try to integrate as much as possible energy infrastructure. You really try to integrate new appliances and innovations, but at the same time, you really try to organize a local energy market. You produce electricity, you exchange electricity, and you trade that electricity in a very specific local area. You try to install ICT systems to support the entire system, and you transfer energy to consumers, vice versa, and no longer the one single way. Finally, what we discovered from the studies and the projects we conducted in several countries, what is really important if you want to implement smart meters and smart grids is to join forces and the willingness actually to work together. And that is being reflected in what we call the end-user acceptance and participation. We conducted several studies in countries in Europe and outside Europe, and out of that it became very clear that you need some preconditions coming from the end users if you want to use smart grids and smart meters. In most cases, it's very simple. Yes, they do like electric cars and they want to use them because they are needed in the grid. They actually want to participate in the production of energy. So instead of consumers, they become prosumers. They do believe in saving money using CHP and solar panels. And they do like, and they want to apply, and they want to use smart home appliances. Let me finish, ladies and gentlemen, by give you a brief overview of some of the smart grid field trials in the Netherlands. And the most striking one is the so-called Power Matching City project. This is actually a real-life example of smart grids and smart meters in the Netherlands, in Hoogkerk, northern part of the Netherlands, whereby we combined and we interconnected 25 homes, actually, 25 homes, with each of them having a variety of smart grid appliances. So that was a cooperation between DNV Kema and other market players, whereby we had a really, really tough challenge, because we wanted, not just in a laboratory setting, but in a real-life setting, we wanted to integrate renewables, but at the same time aim for consumer acceptance, try to integrate both electricity and gas grids, and we demonstrated how gas appliances on the production side, situated at the end consumers, can actually help in reducing the peak demand and, in the grid. Results to date are quite positive. We see that the people really like the idea. They are very, the response is very positive. And we see that with that interconnected system, we have much more flexibility in the grid and in the entire system. And it also proves that there is some kind of interoperability. Systems really work and systems can really be integrated. This is not the only project in the Netherlands, Hoogkerk. We also have the so-called Smart Energy Collective. This is really a large-scale project, not just connecting 25 houses, but actually connecting 1,500 smart grid, commercial and residential end users. It's a combination of 26 Dutch companies trying to work together, and our aim is really to initiate that bidirectional communication and exchange of energy. And once again, and it goes without saying, we try to integrate decentralized energy production, testing, and we try to really encourage the end users to use smart grids and smart meters. We are running out of time, so I will not go into the details for the last pilot projects, both in Amersfoort and Utrecht. Those are smaller projects, actually, also based on the integration of solar energy, electric vehicles, and electricity storage. This, ladies and gentlemen, brings me to the end of my presentation. I hope I could really show you in which direction the market, the energy market structure is going to, and what the role and the importance of smart grids and smart metering actually is. And let me give you one last thought as some kind of reflection. As with every new innovation, it takes some risk management and some guts to really go beyond the borders and try to explore new technologies. But with some decent risk management, it's a bit freaky, but it's feasible. This concludes my presentation, ladies and gentlemen. Thank you very much for your attention, and I will be more than happy to answer any of your questions.
Thank you very much, Mr. de CORTE. Your presentation makes it much more clear what is the lateral power Mr. Henrique was talking about yesterday, especially from the consumer side, as managers and producers of their energy. And if you take a look at consumers and the consuming market of energy, we see it's a very unbalanced one. On the one hand, we have a small portion of humanity consuming too much energy, maybe because they don't have this management tool. And on the other hand, we have 1.3 billion people who still do not have access to energy and will not without more intelligence supported. So I would invite Mr. DROZDOWSKI for his presentation now.
Dear Henrique, dear Emmanuel, ladies and gentlemen, let me start by thanking you thanking the organizers for their invitation, and saying that it's an honor and a real pleasure to attend the World Forum to share GrDF view on smart grids, especially after such a thorough presentation where the part of distributors has been raised. If you agree, I'd like to go through a three-step presentation. First step, I'll quickly share some highlights about GrDF, so you know about our company. Then I'll share a video of 4 minutes with you showing how we prepare to 2030. And finally, we'll dig into what we see as smart grids and the different technical aspects that we'll go through. For this last part, if we jump straight to the conclusions, there are 3 keywords that we'll go through. There's energy efficiency. We will go through different actions that we have to work on energy efficiency. Energy savings, we will see what actions we have to enable our customers to have a better understanding about their energy consumption and to trigger eco-friendly actions. And finally, last keyword, green energy. We will see how we work on green energy's integration in our networks, and especially biomethane. Okay. So a few words briefly about GrDF. GrDF is the leading natural gas distributors. It has 4 main missions: channeling natural gas for natural gas suppliers without discrimination, providing public service in natural gas distribution, of course, securing quality, safety, and economic performance of our network, and developing it, ensuring the development of our network in a cost-effective way. So about some highlights, we have more than 11 million customers. We have a network length that is equivalent to 5 times around the globe, which is a nice figure to have. We serve more than 9,400 communities, which is equivalent of 77% of the French population. We deliver on a yearly basis 350 terawatt-hour of energy, so 350 billion kilowatt-hours. We invest on a yearly basis 700 million euros in our infrastructure. We have a workforce that's equivalent to 12,000 people. And now, time for the video to share our 2030 vision, please. Thank you for your attention. Yes, and now let me elaborate on our vision of smart grids. Smart grids for GrDF have two sides. There are two parts. We have our smart metering project, that's at the bottom of the slide, and we have the different macro functionalities of a smart grid that you can see on the top. So let me start with the smart metering one. This is not necessarily a part of a gas smart grid, the way it is for electricity, for instance. In gas networks, we do not have real-time constraints as such, like the one we have in electricity networks. But it's a real tool, and we will speak about this in the next slides, to empower customer to understand their energy consumptions and to take action to trigger energy savings. The upper part shows the macro functionalities that have been defined, but that by the task force on European level, that's called the Expert Group 4, and that provided us with conclusions that are here, these macro functionalities. Smart grids, gas smart grids, are defined as flexible grids. We'll see that flexible refers to the ability of a smart grid, of a gas grid, to store energy and to build links with other networks, such as electricity and heat. Acceptance of non-conventional gas. We will talk about biomethane that we've mentioned already. Operation, safety, continuity of supply. This is easing and improving the quality of service that the distributor can provide. And smart gas utilization. This is the technologies that have been shown in the video earlier. We will see that energy efficiency can be improved using some specific gas fuel technologies. So let's start with the smart metering project. The smart metering project we have basically consists in rolling out 11 million smart meters in France. So every household would have a smart meter. Our key success factors are listed on the left side of the slide. We work for consumer satisfaction. We work for energy savings, and we'll get back to that. And for DSO, so distribution system operator efficiency. Basically, we have three key technologies that serve this project. The smart meters themselves, so 11 millions, that will be communicating with 20,000 concentrators, and that will be communicating with information systems that we have to update or deploy new versions of some of them. About the calendar, we started, and I think this is very important, we started with experiments bringing around the table social landlords, local authorities, consumers. So this is, we've involved 20,000 households around on this part of the project. So to define the best technical specifications of the smart meter that we're considering today. Today we're in the second phase of designing, of construction, and of testing the smart meters, updating the business case. The business case that is presented to the CRE, the French energy regulator, that is expected to provide us with an answer mid-2013. So mid-2013, the French energy regulator will say if they agree or not to deploy the smart meters on our territory. The rollout is planned to start in 2014 and to end in 2020. So let me get back to the energy savings. This is an important part of the business case we're sharing with the Energy Regulation Commission, since it is part of the benefits. Deploying a smart meter has a cost, but we think that it will allow every household to understand its energy consumption and to react, so to save energy, and this is a saving that should be put into the equation. The way we look at it, we're working with the French Environment and Energy Management Agency, the ADEME, on understanding the impact of a smart meter. And the way we look at it, we divided the impact according to 3 information channels. First channel being improved information. It's simply you have an invoice that's based on real data, and this allows you to understand it's not estimated data, it's real data. So you have so you can already react, and you can already have a better feeling of what you consume every month. Second information channel, once the smart meters are deployed, are new services that will be able to be developed by service providers. For instance, an alert, for instance, if you set a threshold of your energy consumption, saying, okay, I want to be warned when I reach 80% of my monthly consumption, I want to receive an email or a text, and this is the kind of service that we think will have a small impact as well on consumption. And final channel is the information that we will be able to provide to social landlords and local authorities, so to allow them to better trigger the action, maybe better trigger the district, identify the action, identify the district, identify the type of action that's required, thanks to real data consumptions. So this is basically what's shown in this slide. So we have the 3 channels: improved information, new services, improved information going through third parties, and the whole game is to understand what kind of reaction, of course, for residential and tertiary we expect, who will read this information, who will say, okay, I received it and I understand it, who will then act, who are the households that will say, okay, I received this information, I understand it, and what I do is I diminish by 1 degree, for instance, the temperature in my house, or I put a thermostat, or I change this device that is old, and then calculate energy savings. So these are the first saving assessments that we're sharing with the ADEME at the moment. Taking only the 2 first flows, we arrive to 1.5 to 2% of yearly gas consumption savings, based on the 2 first flows. And I'd like here to mention, because this is really the 3rd floor is a bit trickier to address. I'd like to mention an operation which is called Reflex Energy that takes place in Dunkerque urban community, which gives some insight on this 3rd floor, third flow, when you have people helping you understanding, when you have attendant measures, you reach much more energy savings. For instance, here, I think it's on 21 households. That's an experiment that started last year, which achieved 12% of energy savings. So this is really something that's interesting that we are currently looking at closely. Getting back to the 4 macro functionalities of what smart gas grids are. Let's start with flexible grids. They refer to the ability of gas grids to store energy. Storing energy is basically here on this example. It's a link that is deployed between a power infrastructure and a gas infrastructure. Here it was mentioned before already. For instance, hydrogen could be an option. When you have renewable energies, when you have intermittent energy that's hard to store, one option is with this kilowatt hour that you cannot consume. Well, you turn it into hydrogen, and hydrogen you can whether inject it into the gas infrastructure straight away. We're carrying out tests in Dunkerque now to see how our gas infrastructure and the gas utilization reacts with 20% of hydrogen. So whether you put that into the gas infrastructure, whether, and this is the time to market is a bit longer, you take CO2 from some industrial processes, exhaust fumes, for instance. You take CO2 and you mix it with hydrogen through a mechanism that's called methanation, and you get CH4, you get natural gas that is seamlessly injected into the gas infrastructure. So the ability of gas grids to play a storage role really depends on this kind of technologies. Hydrogen from the power infrastructure to the gas infrastructure, and micro CHP. We'll speak about this a bit later. It's another link, but that goes from gas to the power infrastructure. It's a technology that, for instance, you can deploy in homes. So it's a decentralized energy production means that allows you to produce energy and heat really where it's needed without all the losses that you can have on the way for electricity. So this is, we think, an interesting technology as well. Second point is acceptance of non-conventional gas. Again, a very concrete example. In 2011, started at Lille-Seguin, a green waste processing plant. Basically, you take waste, you put that into a processing plant. It gives you biogas, and when you evaporate the biogas, it gives you biomethane that you can seamlessly inject in our infrastructure. This is an example where Lille looks at fueling buses with biomethane. So it's this is an application, and we have currently 278 projects of biomethane that are currently studied at GrDF. So people asking for information: how much does it cost? Can we inject at this place? And this is ongoing. So in France, for now, we have one injection plant, but in Germany, it's a much more it's a mature technology already, but it's much more deployed in Germany. Speaking about biomethane, waste methanization. So this example at Lille-Seguin is the more mature technology. It has the biggest volume of the biggest opportunity. We assess this at 210 terawatt hours. We have other technologies that appear as well. Solid biomass gasification, for instance. So this is elements, as you've seen on the video, elements taken from wood that you can digest in order to create biogas. You have microalgae. So this is a longer time to market. This is basically about creating your own biomass using exhaust fumes again in order to turn it into biogas. And finally, we've already mentioned that we have hydrogen and methanation. So for us, and the latest figures from the ADEME say that in 2030 we expect 17% of what we call green gas in our networks. Okay, operation safety and continuity of supply. Well, this is basically a feature that stresses the fact that our core business is also evolving with information and communication technologies. We start with remote monitoring. We expect remote control, dynamic SCADA, injection and control of biogas to appear. So this is a really step-by-step evolution, and we integrate innovation into our core business. Keeping a close eye on cost-benefit analysis, of course. Basically, the main benefits expected are security of supply, so continuity of supply, optimization of our operations. For instance, today we already have several thousands of points, of control points, controlling the quality of the pipeline. Instead of having someone going on site and checking what is the status of it, we have some device that send out the information. It's much more efficient that way. And of course, biomethane injection. Just a small word about it. Compared to renewable integration, meaning wind power, solar power, we don't have exactly the same problem for biomethane, which is so green power integration. When you a producer of biomethane can exactly know, it's very easy to forecast the production. The challenge is not forecasting the green production, it's more adapting consumptions, because during the summer you have a lower gas consumption, of course, and you need to be able to process and to whether to store, whether to diminish a biogas injection at this specific time. And last feature, smart gas utilization. Well, basically, it's so on the left side you have. Well, let's start with the bottom of the slide. This is on the vertical axis. You see primary energy efficiency. So basically, it is the difference between the energy delivered by a device and the primary energy that's needed for to fuel it. For instance, direct electric heaters are very low because we take into account the average average performance of the electricity power plants in France and taking account electricity losses on the way. So that's why this is more or less 43% of energy efficiency. Above that, we have condensing boiler, and actually we have conventional boiler, and above that, this is the more, well, we have a market share of 40% today. The condensing boiler, our technology that sells in France. And it has only a 5% loss between the gas that's used as an input and the energy that's delivered. What we see is, starting from this condensing boiler, we can even improve the performance by adding, for instance, solar thermal to that. So that would be on the left side of the slide. And on the right side of the slide, these are technologies that are not only gas, but that are hybrid. Whether it is by making, for instance, making an arbitrage between the price of electricity and the price of gas in order to produce heat. This is that's what this kind of technology allows, and as we mentioned before, CHP. So you connect a device to the gas network in your house, and this, in a decentralized way, produces electricity and heat where it's needed and when it's needed. So these are what we call smart gas utilization. So as a conclusion, we think that smart gas grids are part of the wider smart energy network, and the expected benefits from this approach that we think at the territory level. So this is really, we have to take into account at the territory level, what are the existing networks, what are the existing technologies, how we can optimize energy efficiency at this level. The expected benefits: consumer empowerment, improved energy efficiency, we already mentioned that, and biomethane injection, so greening the gas that flows through our infrastructure. Thank you very much.
Thank you very much, Mr. DROZDOWSKI. As our first speaker, you also see smart grids as an energy evolution more than a revolution. So maybe we have a consensus here in statement. I have a set of disturbing questions myself. I don't want to take much time with that and give you the opportunity for you to make your questions. I will just address one question for both speakers, and I would like to hear from you your vision in terms of who must pay for this technology, especially when we talk about smart meters that have already been implanted in some parts of the world. Should it be shared by consumers, utilities, governments, or not? And especially, is already possible for smart grid suppliers to calculate and to demonstrate in how much time investments can be payback in terms of saving energy? So can we start with you, Mr. Decourt?
Okay, thank you very much for that, I would say, highly relevant question. I must say, we are being confronted with that question every time we set up a project somewhere in a country. To be honest, it's a tricky question. Because, let's face it, if the final aim of rolling out smart meters is that every end consumer can benefit from it, can inject energy into the grid, can save energy, in most cases what we hear from the politicians is that they prefer socializing the costs. So in that case they say, well, all the end consumers who actually have access to it should pay in the costs. So it should be divided over all the users. However, what we see is that in most cases when we go for that approach, the initial investment is so huge, in some cases, especially when you go for the massive rollout, that the cost is way too high just to spread that also over the end consumers. And in some cases, we hear the message coming from governments that they say, we don't go for a massive rollout, we go for a gradual rollout, and during the first stage, not all end consumers will really have to pay for it. Just touching upon your second question, payback time, that very much depends actually on what kind of smart meter you want to use. And that's also a very common problem, I would say, when you are considering rolling out smart meters. The spectrum is very, very broad. As just explained by my colleague, you can go for a very simple passive smart meter that you just use really to make it visible, to make it tangible how big or how small your energy consumption is. And in those cases, the investment cost is really limited, and payback time is of course much shorter. If you really go for the more advanced smart meters, where you can actually use dynamics and really use the appliance to shut down specific energy consuming appliances, then of course the payback time is much, much higher. So it all depends on what kind of smart meter you want to use. And that's a very difficult question. If governments ask us, well, do a study on cost benefits of smart meters, the first question we ask is, what kind of smart meter do you want?
Thank you. Yes, in this case of that I've presented, we go for the low option. And about the figures, so at this moment we assess that the whole project cost 1 billion euros. That when you take off from this this budget, the replacement that should have been done if the smart meters weren't deployed, so the standard replacement of meters, we dropped to 700 million euros. And that if we take into consideration the energy savings that we believe will be achieved, so between 1.5 and 2%, we arrive at for the globally, it's a beneficial or null project, budget-wise.
Oh, thank you so much. So now, questions from the audience. I would ask you to be kind enough and to identify yourself before asking, and try to be as straight to the point as possible, so that we can take more questions.
Thank you. My name is Raj Shinde. I come from India. Congratulations for a very excellent, clear and simple way of putting this concept of smart grid and smart meters. My question to both of you is that you are given a very good projections up to 2030, including just now what you said is about 1 billion euro, which is needed as probably the first cost. And I'm sure there are also similar costs in what you are doing in Netherlands. The question is, knowing that today's financial crisis and is going to take some time for the Europe to go through it and stabilize the economy, do you think these projections, what you made, for example, roll out by 2014 or so, is it realistic? Has it been taken into consideration, the existing financial crisis, and the budget's allocations have already been done, or you think it will happen eventually?
Well, I confirm that our teams are getting prepared. Now we started presenting an update of the business case that have been presented already last year to the French Energy Regulation Commission, and it's we believe we will have a green light. This is what we're expecting, and so as I said, mid 2013, it will be the decision will be given. Yes, we're really insisting on the fact that energy savings, really giving out this smart meter the way we've defined it, the technical specification we've built. The smart meters give you, it's a tool to achieve energy savings, and taking into account this energy savings at the scale of deployment that we have, again, 11 million, it's yes, it's a coordinated action on the scale of France, that the energy savings will cover the overcost of the smart meter. Sorry again? Who will pay for the energy saving? Well, this is each household has a lower invoice at the end of the year. That's each household will benefit from a better understanding, and so that's the way we look at it.
Just referring to your question, and thank you for your question. Let's face it. The directive is what it is, and it has a clear date, and it has a clear obligation for member states to have those smart meters. However, and that's maybe will be the escape route, it also says that it has to be economic, feasible, and realistic. What we see now is that member states do not just worry about will it be economic viable, but they just start worrying about the date which is approaching. So they really see it will be pretty difficult to have every smart meter ready by the date as suggested by the European directive. And that is really the current problem. And that's the reason why all European countries really start running around and asking for cost-benefit studies just to see will it be feasible. And indeed, I totally agree. When you just look at it, as my colleague said, from energy savings and from the end consumer point of view, in some cases, it is economic viable and feasible. But let's not forget that if we are talking about smart grids, then you need much more important investments. Just to give you a number, a calculation has been made, what is the additional cost of investing in the Dutch grid in order to have, by 2032, a really operational, full-scale smart grid? It is 1.5 billion a year, only for the grid operators to invest towards a smart grid. If you stretch that over the period until 2050, the number is much more considerable. It varies between 20 and 75 billion euros. So that also comes on top of it, which does not mean that it's not beneficial, but the investment cost is really high.
Nicolas Dinter from France here. Smart metering is very good to save energy, as you said, but there is a lot of things to do for educating people to learn how to save energy with the smart meters. Are you involved in the education of people to save energy through your technologies?
So the question is about involvement on educating people about the energy consumptions. Yes, we've mentioned that. There's this field test. We work through field tests in this urban community of Dunkirk. So we are seeing, and by the way, our research center is involved in research projects, so to assess what kind of information do the households understand, what make them react, and this is ongoing work, and absolutely we are looking at this at the best way to educate the households. So it goes from just giving a reference, you live in this type of apartment, you have this kind of family, you have a bathroom that has only a shower, or you have more, and so the households, the standard households, knowing where you are, consumes that much, and you are above or below. It goes from this kind of small reference to really actions that are dedicated to some districts that are that are consuming too much compared to those standards, and to really see, okay, is it a matter of changing the equipment? Is it a matter of isolation? It is a matter of simply making people understand, okay, you can, you can manipulate your thermostat, or set when you go away or when you go on weekends, you simply make this change. So we have different actions, and I think, yeah, we're working on this.
Hello, Juliette Sénéchal. I have a question for both of the speakers. I would like to know who will be the contracting party of the owner of a building who wants to trade his energy on the grid.
Thank you. That really depends on the situation, whereby I mean, if you imagine that you have an apartment with several housing components, you even could have every single apartment owner who actually has energy production capacity trying to sell its energy to the grid. You could also consolidate that and act as an entire structure. And you could even expand that to having several apartments working together and really consolidating the produced energy and selling that to a local energy market, or even selling that off to the grid to other users. Whereby I also want to make just one small remark. Smart meters and smart grids are really important and interesting, and they can also help in trying to balance the grid, because this is actually an aspect we've not touched upon yet. There is a role for transmission system operators and distribution system operators to actually balance the grid. So every demand should be leveled out by production. And the more you have the decentralized production, the more difficult it becomes for the grid operators actually to balance that and to level that out. And so the more you work in a fragmented way, the more difficult it becomes for the grid operators to really maintain that balance. And so it's actually not facilitating their role, and in some way smart grids and smart meters can help them in trying to stabilize the grid. So it's very wide. It's very, very wide. We see the first projects now whereby we try to integrate a market structure and some kind of local power exchange, and we're still looking at possibilities to really structure that.
This is Stefano Scogna, and I've got a question from the gas utility. Lower gas consumption means also that you may face a lower revenue from a lesser sales of your product, which is gas, I assume. So how you compensate that loss of delivery of the gas? And secondly, if you have thought to bring the banks into the picture of helping us, households, to buy those smart meters. And sorry, maybe too many questions, but also I've got a question about hydrogen. And hydrogen production at the moment is not energy efficient. So how you produce your hydrogen, whether with methane splitting or with hydrolysis and whatever. And then the last question, I do apologize to be so long, is I've seen that you were planning about biogas, biomethane and stuff. And I've seen the picture of the plant of corn. Now, in my opinion, this is a bit disturbing because we risk to convert food for energy, even though there are so many debates about how to overcome this. And so, sorry to be so long, but maybe.
Okay, so I'll take them from the end. And
thank you for your time, anyway.
Regarding the last point, so for biomethane, in France you can only take waste from urban waste or agricultural waste, so there's no competition. So that's the first.
You have showed the pictures with the pigs, and then my assumption was that agricultural wastes, but you cannot have biomethane just by the excrements, the droppings of the pigs. You have got to integrate it with cereals and in the diet of the digester. This is my understanding.
Okay.
So this is if you. I was just wondering if you would have used the traditional way of producing biomethane, integrating the droppings of the animals with some cereals that can be eaten.
I got it. I don't have a question. I don't have an answer specifically on the pigs. I'm sorry, but the no, of course, on the video it was shown. You're right. For the field test we're working on, it's only urban waste and agricultural waste.
Si j'ai bien compris, il y a deux parties dans votre explication. Il n'y avait pas venu sa réponse. I'm sorry.
So third question. So that was the fourth. The third question was hydrolysis. That's the answer. It's hydrolysis that we're working on in Dunkerque to integrate ethane, so a mix between natural gas and hydrogen. Second question: do we bring banks into the equation to help households? At this stage, I don't think so. No, the question would be no, but I'll confirm that. I don't think we have gone so far. Yep.
I'm Italian, and in Italy, to promote solar panels on the roof, they have called into the banks. So for very small solar panel systems, citizens didn't pay anything. The banks had all the benefits, the economical benefits for 7 years, and then from that moment on, the occupying person of the settlement would have. So this is the same system would have applied also to your smart meters. I do apologize to talk too much. Sorry.
Okay.
Donc si j'ai bien compris, dans...
dernière question.
Oui, dernière question. Alors.
And regarding, so it was gas revenue compensation. So this is something we're in the infrastructure branch, and we're not the gas supplier. GrDF is really independent from the rest of the group, so we are only working on the technological side, and it's more than
exactly.
They will develop services. There will be, I think, different options.
Donc, si j'ai bien compris, il y a deux aspects dans votre conférence, dans vos conférences. La première, c'est la création de l'énergie, et la deuxième, c'est le comptage de l'énergie dépensée chez les particuliers avec un relevé automatique. Alors, il y a une chose que vous pourriez déjà faire très simplement. Parce que quand moi je veux vérifier la consommation de l'électricité ou la consommation du gaz pour dire à ma femme de fermer les fenêtres quand elle s'en va et d'éteindre la lumière quand elle quitte une pièce, et à mes enfants, ce serait qu'on puisse lire les consommations électriques sans devoir se mettre à 4 pattes en prenant une lampe électrique pour lire les chiffres qui sont illisibles. Alors vous feriez un système pour projeter les chiffres au plafond, avec la consommation de l'année dernière et la consommation actuelle, on pourrait déjà tous faire des économies et ça coûterait pas très cher. Moi, j'ai un réveil qui projette l'heure au plafond et ça coûte rien du tout.
Thank you for that question. We have a few answers. For electricity, you're right. Usually people can open their the cupboard where it's hidden and look at the digits. For gas, in 70% of the cases, the gas meter is outside the property. It's en limite de propriété. So you have to go out to have a specific key to open a specific box where the gas meter is hidden. So that would be a first thing. Second thing, you mentioned the yearly consumption. It has to have a little intelligence in order to record this yearly consumption. So I think, what you expect will be delivered by the smart metering project we have.
Merci de votre question. I will answer in English. We were involved in a couple of projects in the US, and we were focusing on the awareness and how people make aware of energy consumption. And I totally see your point, and I'm happy to tell you that in the US what we did was a specific project focusing towards children. How you can make children aware of energy consumption, because let's face it, they go out, they leave the door open, they leave the lights on, and the parents have to chase them. We just used a smiley, a simple smiley, a big smiley, and it changed. And if children let the doors open and they let the lighting on, then there was a negative smiley. And the parents could tell the children, well, yeah, look, if you do that, if you turn out the lights, if you turn out the music, then all of a sudden you will see a positive smiley. And it really worked. It really, really worked. And we also had other projects with more adult people looking at the awareness there. And what we see was that using new IT appliances, that people really start playing with it. Funny story, we had, you were just telling, well, people going out. We had a couple of colleagues who were involved in a project to actually control their energy consumption from a distance using tablet and handheld Blackberries. And in our German office, we had one American colleague sitting with us, and he was actually giving a presentation. And he said, well, I control my lighting and every electric appliance from here. So my wife is still in the US, but still I can control everything from here. And we actually could see the whole energy consumption pattern for the entire day. And we could see, well, yeah, it's about 8 o'clock at night. And the colleague told us, you will see now, my wife will switch on the lighting, and you will see the consumption rising because she's doing the washing and she's turning the lights on. And instead of seeing that, we saw that the consumption dropped, and somebody said she's probably going out with another man. So we did not see the colleague for the rest of the evening. But it really works. It's an example how people can really monitor minute by minute their consumption, and they can really work on it.
Thank you so much. Unfortunately, we have no more time for questions. I've been involved in energy discussions for a decade, and I'm very sure this was a very high-level panel with fantastic questions from you. And I want to stimulate you to a warm applause to our very smart speakers and fantastic speakers of today.